are discussing module 6 of the chemical technology course organic, and module 1 lecture 1 we discussed about the various development that has taken place in the petroleum refinery, what are the crude oil quality, how it is varying, availability of the crude oil, and then the changing scenario in the refinery, and what are the various development, and what will the concept of the future refinery. And if you see there has been a lot of variation, we are finding the crude oil quality from the sweet to sour crude, and so the evaluation of the crude oil, that is very important part in case of the petroleum refinery, and for the getting the information about the various product which we will be getting, what will be the quality of the product. So, evaluation of the crude oil, petroleum products, and because these raw materials we are using in the petrochemical complexes, especially the kerosene or the naphtha for catalytic reforming or the naphtha for the cracking. So, requirement is different all this. So, we will be discussing the importance of the evaluation of the crude oil in this area. The coverage will be the introduction, sources of the crude oil in India, types of the evaluation, composition of the crude oil evaluation, then the product evaluation, major parameters of the gasoline and diesel specification, because as I discussed in the lecture 1, there has been continuous change in the requirement of the gasoline and diesel specification. Then evaluation of the feedstock for aromatics, olefins, and the surfactant plant LAB, where we are using the kerosene as a raw material. Now, let us discuss why the importance of the crude oil evaluation is there. Crude oil is complex mixture of various type of the hydrocarbon, although it is, you can say the C and S, but containing a large number of the hydrocarbons, and it is reported it may be around 1000 hydrocarbons that may be present, and along with this traces of the impurities like sulfur compound, metal, nitrogenous compound, naphthenic acid, all these impurities are also present. So, crude oil quality, as I discussed in the lecture 1 also, that is varying in composition and properties from one well to even one well to another well, from one region to another region, from one country to another country. So, this is the changes as we are using the crude oil, both the indigenous and the imported. In other part of the world also they are using the indigenous and the imported crude, and so the evaluation of the crude oil, that is becoming more and that is more important, just to have the exact idea and knowing the blending composition of the crude oil. So, crude oil is becoming more and more heavier, and so as I told you, and so the quality of the crude oil, evaluation of the quality of the crude oil, base of the crude oil, that is very important. Crude oil characteristics have large impact on the processing of the crude oil, because whatever the products you will be getting, the quality of the products you will be getting from the refinery, that will be totally dependent on the quality of the crude oil which is being processed. These are the basically 4 type of the crudes available around the world, that is the light sweet, this is the API, sulfur content is low, lighter so means the sulfur content is slightly higher than the light sweet, but still it is on higher side 1.5, and the API is around same. Then the heavy is 15 to 300 API 1.5, because you see the API as to the API is just reverse of the density. So, more API means lighter, and the higher API means low API means it is more heavier. So, sulfur content 3%, extra heavy where it can be as high as 3% of the sulfur. As both imported and indigenous crude from various oil field is being processed, blending of the crude is very common practice in the refineries. All the refineries now, even the refineries which were totally dependent upon the Assam crude, they are also using the imported crude, because number of refineries in Assam that has come. So, how to meet that requirement and the increase in the capacity. So, they are using the indigenous and the imported crude. So, crude oil evaluation is very important. With the advancement of the technology, the requirement and the scope of the evaluation is also changing, because now the more sophisticated analytical instruments are available and you can have the better idea of the quality of the crude. As I told you, the indigenous and imported crude oils that is being processed in India for production of the gasoline, diesel, kerosene and lube oil, wax and feedstock for petrochemicals like naphtha and kerosene. Sources of the indigenous crude I discussed earlier also in lecture 1. These are the various sources from where, especially the Assam and Bombay high crude, the North Gujarat, Ankleshwar, Rawa and now the Rajasthan crude. But only problem in case of the Rajasthan crude is more heavier, more sulfur content. So, these are the sources of the imported crude: Arab mix, Lawan blend, Upper Jakum, Iran mix, Dubai, Kuwait, Suez, Jeet. These are all from the various sources we are getting the crude oil. Then the types of the evaluation. The primary assay means the properties of the crude oil. Distillation data is generated through a semi-fractionating or the fractionated distillation. We are having this STM distillation, we have TPP distillation. The various type of the distillation equipments are available for evaluating the quality of the crude oil. SART evaluation, that is on routine basis we are doing the physico-chemical properties of the crude oil, fractionating, TBP distillation data, to boiling point distillation data, yield and some key characteristics of the major state-run products, naphtha, kerosene, gas, oil cuts and atmospheric residue. So, detailed evaluation physico-chemical properties already we discussed, these are the things that is required. And the what is the impact, why we are doing the crude oil evaluation? Quality of the crude oil being processed affect the plant capacity, because out of the output of the product, whether we are getting more lighter or more heavier product, that will totally depend upon the quality of the crude oil, or the product which we are getting that will contain high sulfur or the low sulfur, how much actually desulfurization that is needed, everything that will depend upon the quality of the crude. So, the plant capacity, feedstock availability and the quality for downstream units, product pattern and overall economics of the, because as I told you now the all the refineries they are going just to meet the sulfur standard of the SO2 standard for the fuel, and so to meet that stringent condition definitely more hydrodesulfurization that will be needed. Significant effect on processing scheme and the product pattern. The effect of change in the crude quality, change of the product pattern that we are getting from the refinery, that is because of the variation in the crude oil quality, change of the processes scheme, they will have to go for the some of the more pre-treatment units, thorough output, economics and the effluent quality, because this is also very important, because if you are having more sour gases, chances of the contamination of the wastewater that is more and more. As I told you the lecture 1 that the composition of the crude oil, we are having the various type of the crude oil, that may be the paraffinic base, where the paraffins are on a very higher side, intermediate base means the in between paraffin and the naphthenic base where naphthenics are more than 75, aromatic base more aromatic will be there, asphaltic base means the more heavier product there. And the quality heavy crude, sour crude, high tan crude, opportunity crude, now we are also calling the heavy crude the opportunity crude. How to process this, that is also posing big challenge to the refinery. And the last which is the new development is the oil sand. Again here in Canada lot of the oil sand is that is available, and how to use this oil sand, that is one of the big challenge, and already they have started. As I told you in the case of the shale gas and the oil sand already they have started using. Crude oil is composed of infinite combination of the carbon and hydrogen plus contaminants of the hydrocarbons with other elements which are very important, and already I discussed we are having the various bases, paraffinic, aromatic, intermediate, or it may be naphthenic series. Oxygen is combined in the form of the naphthenic acid that is present. Sulfur as dissolved sulfur, H2S or organic sulfur such as thiophenes, sulfonic acid, mercaptans, alkyl sulfates, and various forms of the thiophenes, that is one of the very important because it is very difficult to remove in the process. Now let us discuss in detail about some of the your laboratory testing which you are doing. First part that comes the evaluation of the base of the crude oil, because knowing the quality of the base oil, whether it is heavier or the lighter, we can adjust our the processing scheme. So, the first thing, that is the earlier method, that was the, because some of the correlation that has been given which are being used for just to have knowledge of the base, whether it is the naphthenic or the paraffinic or the aromatic. So, first thing that was actually the crude method, even by seeing the density or the API gravity, you can say that whether the crude is sour, heavier or the lighter. So, this is the weight to volume and the vice versa calculation, that was the, as I told, the API is reverse of the density, that was just to control the checking of the consistency of the crude oil, control of the refinery operation, and give rough estimation of the crude oil quality. So, API gravity of the lighter crude oil may be of the order of 45, whereas in the heavier it may be around 10 to 12. So, API will be lesser, density will be high. So, this is how we density and the API gravity that can be used for the characterization of the crude oil. And the same time viscosity also, that is one of the highly viscous, low viscous. So, you can have a rough idea of the crude oil quality. Now, let us come to the base of the crude oil, because this is the one of the important first step in the characterization of the crude oil, that is the whether it is paraffinic, intermediate or naphthenic, because the further requirement of the octane number or as a petroleum feedstock for the various uses, whether naphtha you are going for the petrochemical or you are going for the aromatic production, or your kerosene, which fraction of the kerosene that has to be, which will be more effective, because aromatics that may present, even the kerosene if you are using for the as a illumination, so more smoking will be the, so requirement that will depend upon the base that you can have the. So, some of the parameters which has been suggested, one is the very important parameter that we are using in the petroleum refinery, also in the petrochemical industry, the characterization factor, Bureau of Mines correlation index and viscosity gravity correlation. This is the characterization factor, that is the 2 boiling point, mean average boiling point, and the divided by density. Ranking, you can have the paraffinic base if the characterization factor is greater than 12, intermediate base between 11.5 to 12.1, naphthenic base is around 11.5, aromatics 9.8 to 12. So, this is how you can characterize the base of the oil, whether it will be more paraffinic or the naphthenic. Another correlation that we are using in the your knowing the base of the crude oil, that is the Bureau of Mines correlation index, and this is the how the with the boiling point and the density that has been correlated, and based on this you can find out the what is the actually the whether it is the paraffinic base, intermediate base or the naphthenic base. Depending upon these values, you can just have a rough idea of the base of the crude oil. So, this is the about the, there is also one actually viscosity correlation constant. This is the base of the crude oil which I was telling, the viscosity of the crude, viscosity gravity correlation, and based on this factor where the viscosity term is there, and that is Seevolt universal velocity, that is one way of the measuring the velocity. Various type of the your instruments are available for measuring the viscosity. So, Seevolt viscosity, and based on this you can have here the parameter is the viscosity, and based on the viscosity and the density, this correlation that can be used for knowing the base of the crude oil. There is one another important distillation. Earlier it was the STM distillation, and now the two boiling point distillation for the that has become very important. And it is done for generating distillation data and for study of the variation of the some of the key properties through the distillation. TBP distillation is carried out at high reflux ratio to obtain the effective fractionation. Another actually the measurement for the quality of the crude oil, Reid vapor, that is also for the product also, the Reid vapor pressure and line and energy indicates the relative percentage of gaseous and lighter hydrocarbon, because again the quality of the crude oil, more gaseous part will be there or more lighter part will be there, that you can get an idea with the help of the Reid vapor pressure and the light and analysis. Cloud point and the pour point for the estimating the relative amount of wax present in the crude oil. Cloud point gives the rough idea above which the oil can be safely handled. One of the problem you see in case of the that is in case of the wax, and even in case of the oil also, it is getting solidified during the winter season. Viscosity indicates the relative mobility of the various crude. Temperature has a marked effect on the viscosity, because is a normally in many of the places where they are using fuel oil, they are facing trouble during the winter season because of the low temperature. Aniline point indicates the lowest temperature at which the oil is completely mixed with an equal volume of aniline. High aniline points indicate that the fuel is paraffinic and hence has a high diesel index and very good ignition quality, or vice versa. Asphaltenes, carbon residue and asphalt content, because these are again very important, knowing the carbon residue which is left after burning, because that creates problem in the engine, that creates problem when kerosene that is being used or other uses. So, carbon residue and asphaltenes indicate the presence of heavier hydrocarbons in the crude. Carbon residue is the measure of the thermal coke forming property, because this is one of the problem we are facing in the refinery, because we are using large number of the furnaces where we are heating the, and even in case of the your naphtha cracker, where so coke formation is there, which is reducing the efficiency of the furnaces. So, it is determined by these are the some of the meter: Conradson carbon residue and the Ramsbottom carbon residue meter. Both the methods that is being used, and based on that you can find out the what is the residue from that particular carbon residue from particular type of the your crude. Flash and fire point is the lowest temperature. The flash and fire point, these are very important because we are handling the gasoline, diesel or the other petroleum products. So, the flash and fire point, that is very important from the safety point of view also, and at the same time from the quality of the product. So, flash point is the lowest temperature at which application of the test flame causes the vapor and air mixture above the sample to ignite. Fire point is the lowest temperature at which the oil ignites and continues to burn. So, this is the two types of methods, Penske Morton's open closed cup is being used for flash point. Acidity, because you see the corrosion problem, that is serious problem in case of the refinery, especially in the distillation column that will be discussing because the presence of the naphthenic acid. So, it is an indication, but the products also, if you are higher acidity, then the chances of the corrosion will be there, and so that has to be avoided. So, it is an indication of the corrosive properties of the product. Color indication of the thoroughness of the refining process, because the normally we are darker shade we are getting, and so you can imagine. But in case of the you find that there is some color in different type of the product, diesel, kerosene or the gasoline we are adding, that do not confuse with that color. Then the copper corrosion test, as I told you, the corrosion problem is the major problem while using the crude oil in the process or the product which you are getting from the crude oil distillation, because depending upon the your desalting process or the pre-treatment process which you are having, the corrosiveness of the crude oil being processed, that will change. So, this test serves as a measure of the possible difficulties with the copper, brass, bronze part of the fuel system that we are using. The smoke point, that is very important from the for the kerosene. So, it is indication of the smoking tendency of the, as a thumb rule, if the more aromatic, more tendency of the smoking was there. It is used for evaluating the ability of the kerosene to burn without producing smoke, because smokeless flame should be there. It is the maximum plate height in millimeter at which the fuel will burn without smoking. So, this is the another term that we are using for the smoke volatility index in the refinery, and from this smoke point you can find out the smoke volatility index. Diesel index, that is one of the very important characteristic of the diesel. So, if from the aniline point you can calculate the diesel index. Water, salt and sediments, these cause the irregular behavior in the distillation, cause the blocking and fouling of the heat exchanger and results in the corrosion. So, the water, salt and sediment determination is also very important part of the crude oil evaluation. Water content is determined by Dean and Stark methods. Sediment and water is determined by centrifuging a mixture of the crude oil and toluene. Salt content is determined by tightening the water extract with KCNS and the AgNO3. Color indication of the thoroughness already we discussed. Another property from the fuel point of view, that is very important, that is the octane number of the product. As I told, the octane number, requirement of the octane number, that is changing. So, octane number is the percentage of the isooctane in the reference fuel which match the knocking tendency of the fuel under test. RPM, because we are having the two types of octane number, one is the research octane number and the motor octane number, RON or the MON. So, this would be the speed of the test machine, and as you see in case of the research octane number, the speed is lower than the motor octane number. Research octane number, and normally we are taking the average of the two, and this is the what we call it the anti-knock index, RON plus MON, research octane number plus motor octane number divided by 2. Gum, again it is the indication of the gum at the time of the test and amount of the deposition during the service time. Sometimes the engines are creating problem, and you must have faced even in case of the ignition in the scooter, and that is especially the carbon deposits are there. But gums, that is determination, that is very important. The first breaking point, this is the temperature below which the bitumen tends to break rather than flow. This is also characteristic of the bitumen that we are determined. Cetane number, already we discussed. Cetane number is the percentage of cetane, just like in case of the octane number, it was the octane cetane which must be mixed with the hexamethyl 9,2-heptane, that is the hexamethyl heptane, to give the same ignition performance as the fuel in the question. stability test, it is used for the evaluation of the storage stability and resistance to oxidation. Acidity, already we discussed about the acidity, what is the importance of the acidity, weathering test for the LPG, this test show the volatility of the LPG. Now let us come to the product evaluation. What are the parameters? Major parameter for gasoline included in the Bharat norms or the Euro norms are the lead phase out, lead free gasoline, lower RBP, less benzene and aromatics. That is now the figure which I told you while discussing the standard, that is 1%. Lower olefin content, limited oxygen content and lower sulfur content. These are the some of the requirement for the gasoline. Similarly, the some of the properties which are being used, I am not going in detail because again it will be part of the petroleum refining course, and if we start discussing all those parameters, that will take 2-3 lectures and methods if we discuss. So, the various parameters which you are using for the gasoline characteristic, that is the RON, MON, lead, gum, oxidation stability, density, FBP, final boiling point. In case of the reformulated gasoline, aromatics, olefins, oxygen, anti-knock index, vapor lock index, that is which I was telling VLI, that is vapor lock index, all those parameters that we are determining in case of the your gasoline. Similarly, in case of the diesel also, because the as I told you, the our environmental standards are becoming more and more stringent. Same thing happen in case of the diesel also. Diesel specification as per the Bharat or Euro norm, that should have the low sulfur, low aromatics, high CT number, lower density and lower distillation endpoint. These are the some of the major actually required, but as I discussed in case of the gasoline, some of the parameters which are to be evaluated for diesel are the density, viscosity, cetane number, distillation range, sulfur, carbon residue, oxidation stability, flash point, acid value, ash and water content. So, these are the some of the parameters which are being used for the evaluation of the product. Now, let us discuss about the, because that was part of the fuel, the requirement of the gasoline, requirement of the diesel, requirement of the kerosene, the smoke point, and that was the important parameter. And the in case of the your gasoline, high octane number, in case of the diesel, high CT number, that was the requirement, and some other properties like acidity or the fire point, pour point, or it may be the sediments, corrosiveness, all those parameters. Similarly, in case of the, because some of the raw material just like naphtha, kerosene, we are using in the petroleum industry, petrochemical complexes for the production of the aromatics, olefins and the surfactant. So, evaluation of the quality of the product of these feedstock, that is very important. So, for aromatics, what we are using? Naphtha, that we are getting from the actually the naphtha which is having the higher octane number, or even in case of the aromatic, the low octane number naphtha, where we are, because there are two operation in case of the two objectives we are performing in case of the catalytic reforming, whether it is for the production of the aromatics or it is production for the gasoline. So, the aromatics production here also the same catalytic reforming process we are using, and so the naphtha that we are using, pyrolysis gasoline which we are getting from the cracker plant, especially the naphtha cracker, LPG, because from LPG to aromatics the process technology available. Then the olefins, ethane, propane, naphtha, gas oil, these are the raw material which we are using for the production of the olefin, because the quality, if you see the quality of these feedstock, that will affect the product quality from during the aromatic production or the production of the olefins or the for the surfactant where the kerosene for paraffin, because the what we are using, we are separating the particular carbon number of the kerosene. So, evaluation, why the evaluation that is, and the benzene of course that we are using from the catalytic and this aromatic complex for the, because what we are doing, we are converting the paraffin to olefin and then alkylating, we are getting the linear alkyl benzene for making of the surfactant or detergent. Already we discussed about the LAB plant. So, what are the requirement for evaluation of the feedstock for aromatic? Why we need the evaluation? Input cost of the feed constitutes a major portion of the variable cost of the production of the petrochemical, because this is the reason why the depending upon the cost of naphtha, cost of the natural gas, the cost of the whole steam processing or the process, that will be affected. Cost of the ethylene, propylene or the other products which you are getting from the cracker plant or the aromatic, that will be directly related to the variation in the property of the car. So, major feed input naphtha, kerosene from the refinery that we are using there in case of the. So, the evaluation, that is very important. Feed quality monitoring and improvement efforts are therefore very important aspects, having significant impact on the economics of the operation, which I told you, because all the products which you are getting from further processing of the aromatic and this naphtha, that will be affected if the lower aromatic content is there, or if it is more aromatics from the cracker point of view, as we prefer more paraffinic. Similarly, if the aromatics are there, that is going to affect the quality of the kerosene, but there in case of the LAB, what we need in case of the petrochemical, that will be the your carbon number. So, the precursors and undesirable constituent in the feed, including the catalysts and adsorbents, poisons, should be known, because you see the naphtha, kerosene, we already discussed about the while discussing the Pyrex process, why we are doing the pre-treatment. Similarly, in case of the refinery operation, we are using a large number of the catalysts, whether it is the catalytic reforming or FCC or hydrocracking, in all the processes, that is the pre-treatment that is being done. But if these impurities, even in case of the aromatic production, or even when you are going for the steam reforming of the naphtha for production of the hydrogen, what we are doing? We are doing the pre-treatment, because the requirement of the catalyst poison that has to be removed, just like sulfur or nitrogenous compound. So, they will poison the catalyst, and so that is very important. Desired component for the let us discuss about the olefin production, because here what we are doing, we are cracking of the naphtha, and from the naphtha you are getting the, because both natural gas means ethane, propane, or the naphtha that we are using for production of the olefin, and naphtha is around 50 to 54% of the cracker plant is still based on the your naphtha as a feedstock. So, quality of the naphtha, again that will be totally affected by the type of the crude which you are processing. So, naphthenic yields, if you are using the more naphthenic crude yields olefins of higher carbon number, because normally in the cracker what we are interested? We are interested more in ethylene and the propylene than other C4, C5 gases. So, butane means C4 gases, yield will increase if you are having the more naphthenic. Appreciable with the naphthenic acid that is contained, and the naphthiness also enhance the production of the aromatic. So, the aromatic means more pyrolysis gasoline that will be there from the naphthenic, if the more naphthenic. The aromatics feed are highly refractive and they pass through the furnace unreacted. So, this is the problem in case of the when we are having the more aromatic. and why we are preferring the paraffin. Sulfur, the sulfur in the feed suppress the steam deforming reaction catalyzed by the nickel present in the radiant coil. So, this is the also the problem we are facing if the sulfur, even in case of the catalytic reforming which we are using for the production of the your aromatics, there also the sulfur that has to be removed. Here also the because the hydrogen that we are using here in case of the olefin plant in the cracker plant, that is also very important, one of the very important parameter, hydrogen to hydrocarbon ratio. So, if this is the more sulfur is there, so that may be present in the your hydrogen. Some of the physical property desired for the which we are determining, that is the density, distillation range, they are useful to give a rough assessment of the feed quality. Ethylene, the following components give the ethylene in the decreasing order. Because if you see the compare the cost of the cracker plant and the total cost, that is lower in case of the ethane, propane, and if you are going for the cracker. So, lowest is if you take 1 for the ethane, then it will be higher in case of the if you are using the naphtha. So, the ethane cracking or the propane cracking, more lighter, more ethylene or the propane production will be there. If you are having the naphtha or even if you are going for the gas oil cracking, more heavier fraction will be there, production of the more pyrolysis gasoline will be there. Propylene again depending upon the content of the your naphtha or the gas, the propylene yield also vary, because our interest is in ethylene and propylene from the naphtha cracker or the gas. So, this is the how the from the isobutane to isopentane, the yield of the propylene that will be affected. Similarly, butadiene, the following components of the feed give the butadiene in the decreasing order. Butadiene also, because especially in case of the cracker plant, naphtha cracker, we are getting a very valuable byproduct butadiene, and which is, although the other actually the roots are there for making butadiene, but the in naphtha cracker olefin plants we are generating large amount of the butadiene, and this is the reason why some of the mills they are having the cracker plants, they are having the polybutadiene plant, and Panipat refinery they are going to have the styrene butadiene plant, SBR manufacture, and that because the butadiene that will be made available from the cracker plant. Let us come to the aromatic plant. The aromatics are either processed in refinery in catalytic reforming, because that is one of the because what will happen, some of the refinery they are producing the aromatics also along with the reformate which is going to the gasoline pool, or it may be separately processed for production of the aromatics in the aromatic plant. That is just like the where the LFB you are making, where you are making the terephthalic acid. See, in all the some of the petrochemical complexes they are also having, because the in case of the terephthalic or the DMT, what we need the paraxylene. From where the paraxylene come? That is coming from the aromatic plant. So, the importance of the aromatic plant is because of that, and apart from that we are also using the various product of the aromatics, means benzene for making the cyclohexane, and other applications are also there. So, naphtha cut normally 6 to 9, again that will depend upon the whether you are interested for aromatic, whether you are interested for benzene. If you are having the paraxylene plant, the higher cut of the naphtha that will be required, means the boiling point plus 110. If you are interested for both benzene, toluene, xylene, then 90 plus or the around 90 plus, because the boiling point of the benzene is 90. So, paraffins, naphthenes, aromatics, this is the actually boiling point which I was telling. Dehydrogenation of the C8 naphthenic acid, most desirable component that is there in case of the when you are going for the catalytic reforming. Dehydrogenation, that is one of the very important reaction which is responsible for improving the octane number. So, 90% of the C8 naphthalene feed gets converted to C8 aromatics. C8 paraffins, because in case of the catalytic reforming for production of the aromatics, a series of reaction that is taking place just to have the higher aromatic content, and definitely that will improve the octane number also. So, dehydrocyclation reaction, C8 aromatics pass as refractory and directly contribute to C8 aromatics. C8 aromatic precursor, it is useful to monitor the aromatic precursors also. Surfactant, as I told you, we are using huge amount of the kerosene for making of that linear alkyl benzene, because that was the, because we started with the non-linear component which were less biodegradable. Then there was need of the environment to have the biodegradable grade of the detergent. For that the linear alkyl benzene that played very important, because benzene and the paraffin for making the olefin that was available from the refinery. So, the LAB requires the production of the olefins are carbon range C10 to C12 to have more biodegradable detergent. Benzene is required for alkylation of the olefin to produce LAB. So, the benzene again it is coming from the aromatic plant, and this was the reason you see the Nirma that is using the raw material, or even in case of the Gujarat State Fertilizer Complex at Vadodara, they are using the benzene for making the cyclohexane there, which they are using for the making of the caproelectrum. Same thing is in case of the Nirma, because in case of the your Indian Oil Corporation, that Vadodara unit, they are making LAB grade of the benzene. So, feedstock for the paraffins or the kerosene, because we are taking a particular fraction of the kerosene for extracting the paraffins from the kerosene, and so that is going to the for the making of the olefin. So, that the particular cut is there, again we are fractionating, so that we are getting a required carbon number atom and to have the more biodegradable nature of the surfactant. So, desirables requires LAB requires olefin and benzene, as I told you, for alkylation of the benzene. So, at present trend is to manufacture the biodegradable low molecular weight LAB. So, if you are having the lower carbon number, means around NC12, so improve the flammability of the LAB products. Some of the undesirable component in the feed which are sensitive to the molex sieves are contaminants like water, sulfur, nitrogen, oxygen, chlorides and metallic. And this is the reason in case of the LAB plant also, we are doing the pre-treatment of the feed which is going to the molex process. So, these were the some of the requirement which I discussed earlier about the what are the requirement of the feedstock for the petrochemical industry, and the evaluation of the some of the parameters which are important in case of the even the finished product. If you are making the LAB, some of the requirements are there, that is not we will be discussing separately while discussing the petrochemical. So, in the refinery, so the evaluation of the feedstock, that is very important to get an idea about the what will the composition of the product stream, what quality of the product we are going to get, and the whole economy of the plant, that will depend, and with the availability of the some of the analytical equipment. Now, the evaluation that has been be possible to more actually the quick estimation that has been possible, and the accurate method of the knowledge of the various product that we make. So, what are the analytical instrument now available for the evaluation apart from the routine instrument which we are using, that is the gas liquid GLC, gas liquid chromatography, mass spectroscopy or GMS, nuclear magnetic response, NMR, X-ray fluorescence, high and ultra performance chromatography that is available now, atomic absorption spectroscopy for determining the your metal content, FTIR. So, all these instruments are available, and which and the use of this instrument, they have facilitated the evaluation of the crude oil and the evaluation of the paraffins, evaluation of the naphthenic acid and other products. So, this is the all about the crude oil evaluation and the what is the impact of the crude oil on the further processing of the subsequent stage of operation. And one important aspect, that is the first major operation that we are doing in the refinery, that is the crude oil distillation, where we are distilling the crude oil to different fraction which are finding application either as a fuel or as a petrochemical feedstock. So, lecture 3 will be about the crude oil distillation.